All right, in this video, I'm going to show you how to schedule a moon observation, a moon mosaic observation, a color moon mosaic observation on Skynet. So here I am at the Skynet site. You should have a Skynet account, username, login set up by now. Once you're here, well, let me show you around a little bit. This is the main site. This is Skynet 1. I'm going to retire it pretty soon. We're currently building Skynet 2, which is going to be fantastic, but I'm going to show you how to do this on Skynet 1 right now. Just a couple things. Most of the activities here under my observatory. Come back there. Skynet Live is a pretty cool page. It shows you what's going on right now, the different telescopes. Like these are the Chilean telescopes. The weather is good. They're doing their dark observations, something we do before regular observing begins. Some have bad weather, some have technical errors, etc. But it's a nice page. You can see what's going on. Looks like someone is using the radio telescope at the moment. Another cool place is telescope sites. For example, our #1 optical site is Cerro Inter-American Observatory. I can go here. I see recent images, stuff that has been observed, and then the live webcam. This is what it looks like at the site right now. Of course, if you come at night or nighttime in Chile, this may be very dark, though there is a town back here called Vicuña, and sometimes you can see the lights there even at night. If you come up here, you can pick individual telescopes, like maybe I'll pick the Prompt 5 telescope. See it sitting there on its mount. This is a webcam inside the dome. And there's all sorts of good information like filters, the size of the CCD or the detector, field of view, etc., and recent observations. Looks like it's been busy, and the images appear to be good quality. And again, this is a live view, so you come at night, it'll be dark. Now, let's go to my observatory. In this video, we're going to place an optical observation of the moon. And so you come here, and on this page, you get a list of your previous observations. If this is your first time here, it'll be empty. But let's change that. Let's go to add a new observation. Okay. And since we're observing the moon in this video, I just type in moon, and it finds it for me. And this is a view of the sky. It's currently set to Meckering Observatory, which is in Australia. Let's switch the view. We're not really picking the telescope at this point, but we're picking our view of the sky. So here's what the sky looks like at Cerro Tololo, my favorite observatory on Skynet. If I press this, it moves it to the current time. So the sun is still up. The moon is high in the sky. I can go forward a few hours until the sun sets, and then all the stars and planets and things appear. I could draw a box around this and zoom in to the moon. And at this point, we're going to kind of select our telescope. And if you go to the lab, the module 1A, slide down, the first table tells you what telescopes we're interested in to do a moon mosaic. These are the telescopes where this will work nicely. Prompt 2, and it will change from year to year. So this is just the current list when I recorded this video. Prompt 2, Prompt 5, Prompt Meckering, Prompt USASC. These are all identical systems. Prompt 6 is slightly different system, and Hampton-Sydney College is a very different system. So a couple things to look for on this table. Site. If it says CTO Chile, that's our best site by far. It has the least atmospheric blurring, the crispest images. A lot of our astrophotography will do from there, unless you're looking at something that can only be seen from the northern hemisphere. Then we'll try something else. Field of view. This is how big of a region of the sky the telescope observes, and it's measured in arc minutes. And as you can see from this diagram, here's a circle. There are 360 degrees in a circle. And in 1 degree, you have 60 arc minutes. And in 1 arc minute, you have 60 arc seconds. So these fields of view here are like 10 arc minutes or bigger. So about 1/6 of a degree or bigger. And inside the image, stars at a good sight are blurred by about 1 arc second. So 1/60th of an arc minute is the size of the stars. Now, that's the field of view. Here's the pixel size. So the detector, how big are the pixels in arc seconds? And the smaller this is, the more pixels you'll have in your image. Like the Prompt 6 camera is a 2K by 2K chip. These ones above it are 1K by 1K. It's only 1 megapixel. These are astronomical megapixels. They can observe in the dark, very sensitive, very expensive, despite a smaller number of megapixels than on the phone cameras we carry around. Prompt 6, I think I'm going to go with Prompt 6 because it's at a great site. We have extra pixels, small pixels. I should also point out Hampton-Sydney College here. It's in Virginia. It's not the greatest site, but what's cool about this detector is it covers the whole moon in one shot. Anyway, let's go back to Skynet and think about this here. I picked Tololo. Oh, see how much the moon moved while I was talking? If you draw a backwards box, it zooms out. I'll zoom back in again. You can actually pause time for moving by hitting the pause. And let's pick, I said I'm going to use Prompt 6. So that's its field of view. Does not cover the whole moon. So what we're going to do is we're going to mosaic. I'm going to do a 5 by 5 grid across the moon, overlapping grid. And in the analysis, we'll piece it back together to make an amazing picture. Okay, I haven't really selected the telescope here. I'm just kind of viewing, getting an idea. Let's come down here. When I selected moon, it entered the right ascension and declination coordinates. These are the coordinates of your target on the sky. Right ascension and declination is kind of like longitude and latitude here on Earth. Instead of being attached to the Earth, it's attached to the sky. The sky moves relative to us. We move relative to the sky. So these are sky coordinates. Right ascension is like longitude. Declination is like latitude, running from pole to pole, except it's celestial pole. It's a celestial pole. Anyway, you don't have to look it up. It fills it in for you automatically. Now, the other settings. Max sun elevation. In this class, we'll typically observe when the sun is, let me just check my notes here, 12 degrees below the horizon. Okay, at least for bright targets like the moon and the planets. 12 degrees is fine. The sky's still a little bit bright, but it's mostly dark. The professionals don't start until you're at minus 18. So this gives us a little bit of time before the professionals flood the system. Min target elevation, we normally start 30. But sometimes we have to lower it. In this case, we're going to have to lower it. I'll show you that. This means we're not going to observe until the target is 30 degrees above the horizon. So we're not going to observe until the sun is 12 degrees below the horizon and the target's 30 degrees above the horizon. If you're observing close to the horizon, you're looking through a lot of atmosphere, and that atmosphere blurs your image. So getting 30 degrees up or more is favorable. Min visible hours, 0.75, is what we're going to use for this moon observation. It takes time to acquire the moon. You don't want to even start observing if it's not visible for less than this, because you may actually not get it done. We need to get all the observations, all the images taken at the same time if this is going to work, back to back to back. Max moon phase 100. We're looking at the moon, so we're happy to look all the way up to full moon. And moon separation better be 0. Often you want to observe with some separation from the moon. The moon's bright, can mess up your images. But since we're looking at the moon, we're going to set this to 0. Okay. Now, to do this mosaic, this grid, we're going to come down here. The pointing should be 0. We're going to enable dithering. Now, if you go back to the lab and slide down to the second table right here, it tells you for your chosen telescope what your grid spacing should be, how many tiles you need to take. For Prompt 6, I need to do a 5 by 5 to cover all the moon with enough overlap that I can piece the pieces together. And the spacing between the tiles would be 350 arc seconds. Now, if you do something like Hampton-Sydney College, it covers the whole moon in one shot, so you won't actually have to piece it back together. The trade-off is of these sites that has the worst atmosphere and the most blurring. So the image won't be as spectacular, but it is a single shot. So you make the decision. Well, I've decided prompt 6. So that was 5 by 5. And I think it was 350. Yeah, 350 arc second spacing. Okay, that's enabled. So it's going to do that pattern. Now, the last thing you got to do before leaving this page is make sure it's observable. So the Tololo telescopes are listed under prompt. If I come here and click on it, you can see it right here. And this gray line is that 30 degrees I entered. Not going to observe until it's 30 degrees above. And actually, it's only barely above that line. Not very long at all. You want to be above the line as long as possible. It gives you the best chance. And so what this means is this object is in the northern sky. Pretty northern. Well, it's just above the equator, but it's in the northern sky. It's kind of close to the sun right now. So I just don't have a long window of opportunity. So I'm going to lower this now to 20. Click off the box and come down. That lowered the bar. So now I'll come back and find prompt, click it a couple times. Yeah, I have like an hour and a half, maybe 2 hours where it's above the line. Plenty of time to carry out this observation. Okay, next I'm going to choose my telescope. And I've chosen prompt 6. It's at Tololo. These are accordions. And so open up Tololo, prompt 6, and make sure nothing else is selected. Okay, I think I'm good here. I don't think anything else is selected. Okay, and save and continue. Now I'm going to pick my filters. And normally we pick RVB for red, V is for green, and B is for blue. But these filters let in way too much light. And even at the shortest exposure time, we would saturate looking at the moon. The moon's so bright. So instead of R, V, and B, we have other filters that we're going to use. Actually, let me bring up the plot here. Here we go. This is wavelength. Here's the response of the R, V, and B filters. It's kind of similar to the response of red, green, and blue in the human eye. But again, they take in too much light for the moon. So instead of red, we're going to use this filter called H alpha. It's really for looking at hot hydrogen gas. We're not using it this way now. There's no hydrogen gas to observe on the moon, but it's such a narrow filter, it blocks most of the light and allows us to get an image without saturating, even at the fastest exposure times. Instead of V, green, I'm going to use O3. This is to detect oxygen at like 40,000 Kelvin or some really hot temperature. Again, we're not using it to look at oxygen. We're just using it because it's narrow, blocks most of the light. Instead of B, we're going to use U or U prime, whichever your telescope has. And although these are not narrow filters, the atmosphere blocks most of the light in the U. This is almost ultraviolet. And so this will enable us to get a red, a green, a blue without saturating. Okay, so let's come back here. And see, H alpha and O3, you can find that under astrophotography, narrowband. U band is under Johnson Cousins, and if there's no U, you may look for a U prime under SDSS. Again, these are accordions, so you may have to open and close. If I look over here, as I click these, I lose telescopes that don't have everything I clicked. And prompt 6 is still good to go. Prompt 6 has those bands, those filters. Save and continue. Sorry, got a cold, so ignore the coughing. Now, here, if you did the Opus curriculum, we used the generic telescope, and sometimes we will in the MW curriculum. But for this, we just want the telescope we picked. I picked prompt 6, so I'm going to go with that. So since I did a 5 by 5 grid, 5 times 5 is 25, so I want 25 U band, 25 H band, 25 O3. Okay. And the duration, that's also in the lab. If I come down here to the next table, says for prompt 6, I want 0.125 seconds. And I'll update these every year. Sometimes we swap cameras with different properties. So definitely check the lab, the module. And for prompt 6 right now, 0.125 seconds. Oops, here we go. If I go longer, I'll saturate on the bright parts of the moon. I don't want to go shorter. I want to get, a good amount of light. Also, going shorter has its own problems. Many of these cameras have an iris shutter, opens and closes like this. And it takes about 0.03 of a second to open and close. So if you image close to that speed, you'll get more light in the middle than the edge. And that can really mess up your mosaic. You can see here how this was a 3x3. See how the edges are dark? It's because the iris is mostly closed on the edges, mostly open in the center. So we want as long of an exposure as we can to minimize that iris effect, but as short of an exposure, short enough that we don't saturate. Okay, so I have all that. Pick an account with enough credits. You don't need to fill anything in here. Save and continue. There's a review page. You can check your numbers, and then you submit. May take a second. Okay. Oops, I come back out here. Press the button twice and it's sent me here. So now it's listed here in the page, and you can come and check. Right now there's nothing there because I just submitted it. But I can come down and find some other one. Here's maybe go to, here's prompt use ask. This one's in Canada. And so that was also a 5x5 grid. And there you see there's one run through the moon, another run through the moon, another run, and so forth and so on. And that's just the U-band. Once I get through 25 of those, they're loading still. Now it's switched to, this is H-alpha, that's our red filter. It's taking grayscale images, but in each of these filters. That's a grayscale image of red light. The U-band is a grayscale image of bluish light, and so forth. And so you should come back after you put in your observation. You should come back and check here. The key thing you want to check is that all your observations, all your images were taken very close together in time. There's a gap. It's hard to stitch them together because you're looking through different amounts of atmosphere. The telescope, gravity's tugging on it different. There may be small rotations and other problems. So my first image here was at 0054, and as I scroll through, there's 55, 56, 57, 58, 59, 1, 1, 1, 1, 2, and just going through, they all look like they were taken back to back. And this has the U and the H alpha, and often there's a second page. Here we go. Here's the second page. Here's the 03. That's our green band. Continues at 106 down to 111. So these were all taken back to back to back to back to back. So it looks like a good observation. We'll stitch it together in a future video. Oh, the last thing I should point out is that you should maintain an observation log. Here's mine. And this is, you put the information in your log, so and share the log with your teammates. There should be one log per team. And make it look something like this. You have your name, your Skynet group, your username, the observation name, the link in Skynet. If I come here to Skynet, just this link right here at the top. And what else? When it was taken, if there are any problems, any notes. It's good to keep a log here. And if there are any problems, you can just resubmit your observation because these are relatively inexpensive, short exposures, so they're inexpensive. Okay, that's it for this video.